This is Víctor, and we'd like to share with you some of the success and also the failures we have been testing here in Tuenti. Let me do some introduction of our company first. We are the most important social network in Spain. We have 15 million users registered. Well, all these figures you see here, chat messages, a lot of uploaded photos. But maybe the most important figure for us is that we are now 180 engineers. We started 6 years ago as a startup. We were working like 15 of us or 20 of us, more or less. So you can imagine the development process was pretty straightforward. You just had one repository, one branch, you develop your feature. When it was ready, you merge into the release branch and just push it to production. If something went wrong in production, you just go into the server, do some debugging, and then test it. Maybe even all straight into the server, okay? As you may know, this model works pretty well for a little startup, but once you start growing, this cannot be sustained. There is some stuff in a startup, such as the lean movement, the agile you get, because all the information flows. There's not that many people, so more or less you are aware of all the projects that your fellows are developing. But then we grew, as I say. The number of developers grew super fast. We were having maybe 5 or 6 hires, new hires every week. What happened? Not all that people could keep the pace of the changes. They need to do some, read some documentation. It was pretty chaotic. More than that, all the processes we used to have weren't traceable. They were missing a lot of testing. They were not repetitive. There was a lot of tasks that had to be performed by a human operator. Those manual repetitive tasks we usually associate with a release manager, okay, that are not funny and are very error prone, okay? So we needed to do this. Here should be an animated GIF, maybe you know it. He ends up like, crushing his head with a keyboard. And that's what more or less how we release managers at that time used to feel when there was a release. When there was a release, the release could spawn for over 6 hours because we start the releases by merging the branches that were not already integrated into the release branch, pushing the code to production, testing there, reopening the release, doing some fix, pushing again. Then the results of the tests came. We realized the tests were broken, so we fixed yet again, and all those changes went straight to production. Okay, this is a model we cannot. Any big company can afford to follow. So we thought about DevOps. We heard about DevOps. We like the DevOps philosophy. So we tried to set up a DevOps, maybe a DevOps team or something that should promote the DevOps culture and DevOps tool chains and DevOps way of doing things into the company. Okay, so we gathered some team, that is us and some other fellow, that we are mainly developers. We are not sysadmins. We are developers. We are more or less interested in sysadmin. Okay, we have a background of release management. We used to be release managers. Okay. And apart from that, we are people that like to treat with other people. We like to handle people's problems, and we kind of think, I like to think that we have skills with people, okay? That I think in a DevOps team or a team that wants to promote the DevOps culture is very important. So, what then? We thought about DevOps movement, and we grabbed the 3 main characteristics of the movement, or the 3 main traits that we like to implement in Tuenti. Okay, those are the ideas that should be building a platform to allow developers to self-service environments and services, provide a tool chain so they can themselves test, deploy, build, etc., without the need of a release manager, integrate their branches into the main line of development, etc., And also, very important, coach teams to follow this model and promote the culture. Okay? So with that in mind, we started developing and sharing some ideas that Víctor is going to explain.
Okay, the ideas were clear, so we need to put them in practice. We wanted to apply the Devops thing in 20, but you can't say a developer, apart from coding, you're going to do operational stuff. They're going to say no. So we need to elaborate an intermediate solution. So we create some tools to make the life easier for developers to do operational tasks. The first one was Tuenti-in-a-box. Tuenti-in-a-box, well, when the development workflow begins is when the developer starts coding. And what a developer needs to start coding? A development environment. So we provide a development environment self-service, which is called Tuenti-in-a-box, because the one that we had before had some problems. We was growing up in number of developers, and it didn't scale. So the development environment we had before is a classical, here you can see in the top picture, a classical virtualization model with a physical server, VMware, and a number of virtual machines in that physical server. We were growing up, and we were distributing virtual machines per team, per group of developers, and so on. And it didn't scale, so we preferred to find a solution, Tuenti-in-a-box. We developed Tuenti-in-a-box using Vagrant, Puppet, and VirtualBox. For the ones who don't know Vagrant, it's an amazing tool. You should use it. It's awesome. And in combination with Puppet, it's great. So every developer in its laptop can just do Vagrant app and has a full development environment with all the features that that production has. So we avoid bottlenecks and worse performance using the old classical virtualization model. And with Tuenti-in-a-box, everything was self-service. So if you destroy your environment, you can Vagrant destroy and Vagrant up, and you have a new one from the beginning. So every developer has the perfect development environment, and they can get it whenever they want. So the developer now can code, and then the next step is deploy my code, which is finished or complete, to a pre-production server or whatever. So then the next stage is deployment. There are two kinds of deployments: code deployment and configuration deployment. We also provide tools to speed up and ease this deployment for the developers, so they can do operational stuff like a deployment, but made by developers, not by an operation team. The next one was Configcop. Configcop is a tool to deploy configurations to pre-production and to production environments. It builds, tests, and deploys the configurations. How was before? Because, as I said, we were growing in a number of developers, and the previous model didn't scale because the previous model that was a developer going to a production server, doing its config change, and then sending the release manager a patch to apply it. The patch wasn't even compatible sometimes, so we need to do some magic, and that was obviously a bottleneck, a very boring task, and manual, and we don't want to do manual things. So we automate these deployments, and we let developers to deploy even to production, just with 2 command line commands. So Configcop is self-service. It's fast, and you can get stats and logs and so on. A developer wants to apply a config change in production, so let's command line, I want to apply this config change, 1 command. The config change is deployed to a pre-production server, test it. The developer tests it, okay, it's okay, or it's not okay. If it's okay, deploy it to production, and that's all. The process takes just 1 or 2 minutes. And the release manager, or the person who was in charge before, is no longer doing this kind of task, so is free to do other stuff. And this is automated, so no error prone.
Aquí.
Okay. The next deployment method, code deployment. TuentiDeployer, the same. Configcop was accessed. Everyone was deploying their configuration to production with interrupting any other one. So we wanted the same with TuentiDeployer. TuentiDeployer is a code deployer that can perform any kind of deployment to any kind of deployment of any kind of service to any kind of environment. The ideas were that we wanted this tool to be very flexible and extendable by the developers. So we went a step further because the developers could collaborate and extend this tool. When this tool began, we created just 3 kind of deployments, and right now there are almost 30 kind of deployments made by the developers. So now they are using it, and it's quite fast. How was before? Before, every team has its own homemade script. Some of them with bugs, not fast. They weren't parallelizing the deployment. We couldn't control that, so TuentiDeployer fixed that problem. Apart from that, we make the developers know more about the infrastructure because they need to know how a deployment works. They need to know there are static server, front-end server, back-end servers. They are more aware of how is the infrastructure in the CPD servers. Again, logs and stats, which is very useful for the future. And then we developed Flow, which is our main tool that Óscar is going to talk about.
Thanks. Okay, so with these lessons learned, we designed another tool. We have our target, our next target was all the developing, integrating, and releasing of the code itself. Okay, we have learned some lessons from the previous projects, and we targeted the most ambitious project so far. We wanted to develop a tool, a framework that could test, manage integration, releases, give a tool chain so developers could build and deploy their code both to development and pre-production and also production environments. Okay. Also, a very important goal was to promote the transparency of the information to all stakeholders of a release. Not only tech people, but also to product owners, QA, even marketing, so they can schedule their press conferences and stuff. And we liked, up to a point, whenever possible, not to introduce new software, okay? So people that were already following the processes we set up in previous stages could follow the same process. I mean, a developer, when his code is code complete, he will push its code after having it reviewed and tested and also, and then he usually, in more organizations, will go to the ticketing system, to the Jira instance or whatever, and press a button saying that their code is complete. Okay? Well, we don't want then the developer to go to another place, to another interface, to another command line tool, and run another script to say that their code is complete, so please get integrated, to run a pull request. We wanted that if you already are using Jira and you are used to the workflows we set up in Jira, you will keep on using Jira. So, the system, this flow tool, should integrate all the pieces of infrastructure we already have in place, such as Jira, Jenkins for a test, TuentiDeployer mentions beforehand, Fisheye as a repository browser, as well as HE Web, information in Google Docs to make some stats, for example, Hockey Apps, that is a platform to launch development versions of mobile applications. I don't know if you know it. And more important, being a single central point of information for all the company. Okay, so if you want to know what is going on with a release, you should go to your Jira ticket. It's all there. And to get an overview of all releases, code, etc., you can check on Flow dashboard. Okay. Then we designed a tool that would be event-driven. Okay, it will receive events from Jira, from Jenkins, from the developers themselves. Okay, from the repository, hooks in repository, and we'll implement some features divided in modules. Okay, integration pull requests. It was the first module we implemented. It basically handled pull requests for developers. Once your code is tested and code complete, you push it, press your Jira button saying, please pull request my code, and then Flow will get a notification about that. We'll grab your code, merge it to integration to the current master branch, and push it to Jenkins. When Jenkins is done testing your code, it will grab it again and perform the actual merge and push it to the corresponding line of code, and build it and deploy it to a pre-production server so somebody can take a look or decide whether the feature is working as expected. Then we wanted also, of course, to perform our job as release managers. We don't like the release manager tasks. They're usually boring and repetitive, branching a release branch, tagging it, versioning it. All that can be automated. So the model Flow follows is that we create a ticket in Jira, okay, a release ticket in Jira. We press the button saying start release, indicate the change set there, and Flow will perform all the tasks. Okay, it will branch, it will build, it will deploy, it will notify stakeholders with mails with notifications on their Jira tickets. It will add all the tickets included in the integration branches there in the Jira ticket, add the stakeholders as watchers. The information flow is very important for us, as you can see. Then Flow Deployer is a tool, a module from Flow to allow developers to build their code without having the code checked out even. Okay, they just can tell Flow to build a particular change set to a particular environment, press a button, and in some minutes they will get an email saying that their code is already deployed. Okay. This works for every change set and every environment. And also, as I say, dashboards are very important because we want to gather that information that is scattered around all the system. And, of course, having stats and charts to provide the company information about the rhythm of growing, the rhythm of code deployed, the number of hotfixes, and such metrics. This was implemented. Crap. Anyway, I'll explain it. This was an ambitious project, as I say, and as you can see, it's developing a product for an inner tool, a tool for the company, but it's just like any other product development. We have our users, that are the developers. We have our clients, that would be management, because managers have to buy our vision, have to buy that this time they are giving us will mean a return of investment for the company. Okay. What we wanted, we didn't want to give the process an outage anywhere. We wanted developers to keep on developing, to not stop developing. So for that, we couldn't change all the process from one day to another. Okay. So we focused on leveraging the tools we already have. To do so, we try to improve the tool set in place and then give them a wide picture so they fit on some places in this big schema. Okay. So basically, that means that if you used to have a tool to build your code and deploy it, that was a command line script saying build and deploy. We didn't want you to change your tool, because that will make developers confused. When you have a big organization and every week there are new hires, suddenly you regard yourself that you're keeping on explaining the same thing to every new hire. Okay? So we prefer your fellow developers will explain the new hires how to do the stuff, but that only can be done if you keep the processes stable. Okay? So this script, instead of being replaced by another brand new, it will talk with Flow. we prepare a REST API in Flow that will be activated by this command line script that used to do the build on place. Now it doesn't anymore. It talks with Flow, sends a deployment request to Flow, and Flow will perform it. Okay? But you as a developer will not notice. You just will notice because you are getting more accurate information, because the build and deploy is taking less time, and you are, in general, you are reusing the builds, for example, that were built before. So just take a look. This is one of the modules in Flow. It's a pull request dashboard. Don't be too harsh on us about the front end. You know, we are not front end developers. We did our best. But the thing here is that it's a very useful dashboard because you have all the pending queue of pull requests that are going to be processed afterwards. The pull request that is being processed now and fails once with all the information about why they failed. We get from Jenkins the results of the test and put it here, so you don't have to browse through a lot of Jenkins screens. And all these are links to their actual Jira tickets, so you can check. Every change set is also a link to the change set in Fisheye or in HE Web. So for any stakeholder of a release, a developer, a product owner, etc., can just go here and know when their feature is going to be released and how's the state of the feature. Okay? This will be the release dashboard, the central information for what's going on with the release, with our code. So we, for example, have the branches that are already integrated in master branch. They will hopefully be released on the next release cycle. No, those are here. These are the branches on the current release. You have all the information here. You can click on the numbers of the ticket and get to Jira tickets, as I say. Also, Flow, every time performs an operation over your code and over a ticket, will post a comment in your Jira ticket. So if you are, for example, watcher of a ticket, you are not the developer of a feature, but are interested in knowing when that feature is going to get in production, you can add yourself as a watcher of a ticket, and you will get notifications about when that feature is included in a release and when it's put in production. Okay? Hotfixes too. More or less, this will be the central information. As you can see, also we have included support for multiple projects in Flow. We are now managing Tuenti.code, the web code, as well as the code for the mobile applications, Android and Windows Phone, and soon, hopefully, iOS too. Victor is going to give some figures about what this meant.
Well, we started almost 2 years ago with this thing, and the figures demonstrate that it is a success. Because, for example, releases, we were doing 2 releases per week before. Now we are doing 3.21 production deployments per day. That's almost 20 releases per week. And we are not doing them. Developers or QA members are doing them. There is no one operational figure or a release manager guy that is doing the deployments. There's the same for configuration and the same for code, normal code. And also to pre-production, not just production. We are having more than 7 pull requests per day. So developers want to integrate their code 7 times per day. There is no manual task, almost no manual task. There is a little pending thing to do and to improve, but you can ignore them. The developers' throughput increased because they just need to put a button in Jira, and everything is done. They don't need to do anything else. They can start doing another task, continue coding or whatever. They just need to click a button, nothing else. The aging of finished code in our release is really reduced. That's very important. When a developer thinks that his code is finished and code complete and is already tested, the time that is not released is wasted. You need to reduce the time from each code complete and tested until it goes live. The less time, the better. Well, as we are doing a lot of more releases with smaller scope, the fast reaction to time requirement change or bugs is faster, because if we find a bug, just do another release. The process is going to take 1 hour, 1 hour and a half, maybe 2 hours. So we're going to fix the bugs or product requirement change in a short term. We don't need to do a hotfix in a hurry. And of course, information transparency. All the company is aware of everything. Sharing information and sharing knowledge, I think, is the most important thing in a company. Everyone needs to know the state of everything, not only tech people, every company, the CEO, the CTO, all of them. That's one of the main important things that Flow provides, for example. In the future, Óscar?
Okay. So just a second about this, to give some background, okay, because we have said the figures that we are currently using, but some background, when we started all this process 2 years ago, we had 2 releases per week, and those releases involved maybe 30 people being focused on the release process for more than 6 hours in every release. So 30 people, 6 hours, 2 days a week, just to make a release, okay? Right now, as Víctor said, they are almost unattended. There's only some QA monitoring the functionality, and some metrics experts watching the performance and the requests and all that. So, in the future, we would like, first of all, open source our tools. Flow is implemented over a huge stack of open source technologies, such as RabbitMQ, Celery, MongoDB, what else? Huge ton of them, a very big deal. So we'd like to give something back to the community. We'd like to open source tools. What is preventing us from doing so? Because so far we don't think the code has enough quality to release it, first of all, and also that the processes we follow are a little bit coupled to Tuenti's own processes. We'd like to make them some more general so they can fit others' needs. Support multiple SCMs. We are working on supporting JIT. We are not working just with Mercurial. A crazy idea that we have is also making that Flow itself manages its own code. So I can set a pull request of Flow codes to Flow. Flow will test it, merge it, and deploy it itself. That will be pretty nice, and I guess it will be the demonstration that this model works. Another cool stuff we are thinking about is on making risk analysis. As you may imagine, there are some times that we don't have just a pull request going on. Okay, I trigger a pull request, you trigger another one, and maybe 5, 6 developers at the same time trigger a pull request. So we stack them on a queue. What we want to do, we want to analyze the pull requests that have been issued but not yet processed, and try to reorder, instead of just doing a first in, first out processing queue. We'd like to analyze the risks of every tool, of every branch, and try to put, for example, the branches that don't collide between themselves, that have different scope, merge them and test it at the same time, or maybe prepare safer releases that can be totally automated and no monitoring needed, because they just, I don't know, modify. They don't modify core features of the site. And also, with that risk analysis in place, we could do some parallel probabilistic pull request testing. What does this mean? Instead of having just one pipeline of testing and testing all the branches that come merge against the current master branch, we can just imagine that this branch is going to pass their test. Okay? And given that, I will start testing at the same time that I test the branch A, I will start testing branch A plus branch B. Okay? Because I'm confident in that test in branch A will pass. If they actually pass, then I've saved myself a cycle of testing, because I will have at the same time the results from branch A plus and branch A plus branch B. So I can just merge two branches in the same time. I will have merge and test and merge one branch. What if they just don't, the test that just don't pass on the branch A? I have to dismiss both builds, both tests, but that's why we need the risk analysis in place, okay? So our guesses are founded. And we would like to set up this, we are very close to this, a pure continuous delivery. I mean, right now, there are some processes that take longer than we like. So we get some branches merged at the same time, and we have to deploy that branches in a single release. What we would like to do is lower the operational overload that a release has, so we can just, as soon as a change set is merged against the master branch, know that it will be instantly deployed. All the performance testing, all the feature testing, and all that requirements should have been done previously. And that's all. That's our idea. So I know we have been very in a hurry. We didn't want to bore you with all that many. It's a wide presentation. If you have any interest in we give him some more information, some more insight about any particular part, please contact with us. That's our Twitters. And if you have any questions, you are welcome. Something?
Hi, I have one question. What has been, so far, the most difficult thing in this road, in these 2 years? In general, not only the technology.
I think the most difficult part is to changing the way people used to work.
Change their mind is hard.
Yeah, technical problems are hard, but they're funny to tackle, okay? But dealing with people sometimes is pretty difficult. If you have a developer that used to work in the company when it was a startup, he's so used to having access to production servers, to being able to SSH to a server, change some line of code there and put some traces, that when you say that that's no longer supported, that cannot work, they kind of reveal. So the approach we took is to give small changes, not great breakage, small changes, and they all leverage some gain, you know? Instead of doing the old script, you right now have to run this script with this flag, just this tiny change. But this will mean that your code gets much faster to integration or gets in a pipeline of priority, and that way you can show your developers and your managers that every hour of work you put into this kind of project pays off. You don't have to wait for a 6-month-long project, for example, so they get 6 months waiting and then say, hey, what's going on? Are you getting us somewhere or what? We try always to, every single week, every single day, even if possible, to give some change in this infrastructure and in the processes that leverages this kind of vision.
Anybody else? Well, thank you, guys.
Thank you.